All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's October 14th, 2020. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team and then showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/officehours. Again, that's cloudposse.com/officehours. We host these calls every week. We'll automatically post a video recording of this session to the Office Hours channel, as well as follow up with an email that you can share with your team. So with that said, let's kick this off. Got a lot of announcements. The first one is obviously HashiConf is happening right now. So everyone on this call is skipping out on HashiConf. I am flattered, but I understand if you want to drop off now suddenly and go watch HashiConf. So fun announcements coming out of HashiConf. If you go to the Terraform channel right now on sweetops, there is a thread that's been started with the fun announcements coming out that others are sharing as they're watching the video. So it's like the cliff notes of HashiConf are streaming live there. The notable thing that just came out recently was this Boundary. So Boundary is this new identity product that HashiCorp is working on. It's open source, it looks like, and I'm guessing they will find some enterprise spin to it as well. The product is Boundary, and it's an identity-aware proxy kind of solution that you can install to enable users to use their identity to authenticate and access services that you have. So we're talking like anything on TCP, so MySQL, Postgres connections, Redis. Where possible, it can integrate also with HashiCorp's Vault product that can automatically provision users and stuff like that on the fly, short-lived users, and then rotate those out when the sessions expire. So it's a pretty rad solution. It's a busy space. So many, Auth0 has theirs, Okta has theirs, Pulumi has theirs, Strong DM, Teleport by Gravitational. Cloudflare announced their one access product, which is a SaaS. So, I mean, like, there's just so many vendors going into this space right now because of the push for remote work. And this is how you do that securely. I haven't seen yet. I mean, this is me spending 5 minutes looking into it, and I'm sure it does a lot more than that. One of the things I'm curious about is how it exposes internal web services, which is HTTP over TCP. So I assume it should just work. But this is where we would like a good solution, because what we've been using has been Keycloak together with a product called Gatekeeper. Gatekeeper was spun off into its own org. Forget right now what that was called, and then they sunset that like 1 month later. Another failed partnership between them, and in this case, the formerly known as Bitly OAuth 2 proxy project. So Pulumi has been the other big open source option in this space, and Boundary is now maybe the next one. Any questions, comments, or things to add to that about Boundary? Something you got from it?
Yeah, actually, this week, a similar solution was proposed within our team, where we wanted to allow our engineers to have access to production data when they are doing like product support, or even just using like data sunrise to kind of proxy and obfuscate the data there and actually run queries and so on. But one of the issues that we were looking at was setting up something with Vault to do like short-lived accounts to allow, and then also maintain an audit trail with it. One of the solutions that we were also looking at was TwinGate, which is another product, but I think that's a.
Is it also open source or is it?
I don't believe that it is.
Okay.
But this being announced today as well, that there was a bit of a discussion around it as well, to possibly use it in the scenario you actually outlined before. But yeah, it looks very promising right now.
Cool. So I was just trying to find where I could mute my notifications in this web tab. But yeah, thanks for adding it. And I'd just like to add one total non sequitur here. Dale's background, that's actually not an image. That's actually his background. It looks pretty sweet. All right. Any other interesting HashiConf announcements going on right now that I haven't seen? Anything that you're excited about or not excited about?
So I just got some insider information from a HashiConf or a HashiCorp employee about what they're announcing tomorrow, and
well, let's not announce it here because I don't want to
danger, Will Robinson, danger.
danger. But yeah, you can share your sentiment about that announcement without sharing what the announcement is.
They're covering the whole field. It's cool. Yeah, I'll let everybody figure it out tomorrow. But I'm surprised. You know, both of these announcements are huge. Foundry seems cool, but it's smaller in scope than what's going to be announced tomorrow.
Really?
Yeah,
wow.
It's cool.
Wow. Well, I think we are banking on the right vendor to do it. I really love the stuff that they do.
Yeah.
I can add something to this by saying that I'm not actually overexcited with announcement which is coming.
So you're also aware of something, and but that same thing you're less jazzed about.
I think it's different things because the thing which they will announce tomorrow is already publicly available.
Okay.
And this is simply not well known to many people, but it was presented to us as a big secret. And then we say like, hey, but this is already available. And then they say like, no, it's secret. Okay. So we'll see. We'll see. But this big thing which Matt is mentioning, I guess it's really big, but I have no clue what is it.
Okay.
It's also a lot of speculation and a lot of assumption by many people.
Yeah. Thanks, Anton. All right. So the other announcement is we have released our Terraform module, second release now. This is for our Terraform Cloud agent that you can deploy on Kubernetes. This is using the Kubernetes provider and Terraform to directly create the deployment, which is a little bit of a departure for Cloud Posse. If you guys know, we basically wholeheartedly adopt Helm and Helm file for everything. I would say the reason we did this is twofold. It's a foray into seeing how well it works to manage resources with Terraform on Kubernetes. But the other reason is, well, look, this is strictly for Terraform Cloud, which is for managing Terraform, and it's nice to have all the dependencies under one provider, in this case, Kubernetes provider, and not depend on Helm and having other resources managed by Helm charts and releases like that. So this has a very basic Terra test, a simple example for how to use it. Supports every single argument we could find for how to run the agent on Kubernetes. So there's a number of arguments for if you support parallel jobs or single jobs, log level, the token, etc. So if you guys are using Terraform Cloud and have a business class subscription, unfortunately that it requires that, or enterprise, then this is for you. I'm hoping one of the announcements is, hey, everybody at least gets one on-prem runner with Terraform Cloud. Then I'll be really happy. Hint, hint.
Hopefully Scalar provides the pressure there.
Yeah, that might end up being what happens. So the other thing that we're working on, just a teaser, is all the vendors in this space doing continuous delivery for Terraform and like Terraform team collaboration have expressed interest to participate in a kind of roundtable on their products and answer your questions. We're looking at maybe doing something like 10-minute. Sorry, guys. Let me close the door. Shh. No. All right. 10-minute flash talks where they get to present the differentiators of their products, and then at the end, reserve some time for Q&A. So we'll stay posted. We'll definitely be promoting this as a special office hour session once we have it organized. The next big thing, it's not a big thing, is just an announcement that we now have support for all Alpine releases on our Cloud Posse packages repository. This is because of our partnership together with Cloudsmith. So Cloudsmith is a SaaS solution for hosting or managing packages, and it's taken a year before I just kicked the can down the road, but decided eventually to bite the bullet and do it. And the big reason why is they have this cool concept of any version, any release. So what you can do is you can bundle your package, like a Debian package or RPM package, for some software, let's say like Terraform, and you don't have to rebundle it for every OS distribution, for every OS release. You can just specify any release, any version, and then they'll rebundle it for you for the person requesting the package on the fly. So this has reduced some of the complexity for us to manage our pipelines, building packages here. And our workflows for this are in our GitHub Cloud Posse packages repo. And the key thing here is any. So for Alpine, we're specifying any version. So now all the 100 packages that we distribute are now available for all versions of Alpine. We have a pull request coming for Debian, and after that I'm going to do one for RPM. So the benefit with this is that what's planned for later Q4 is that Geodesic, our cloud automation shell, will have a version for all major distros like Alpine, Red Hat, CentOS, Debian, and Ubuntu. So that will hopefully make it more appealing to more people as a base image for cloud automation. And the value here is, of course, that we provide this package repository that has all the tools that you need and all the versions of those tools without using like a version manager. All right, any questions on Cloudsmith or the package repository or what we're doing there? All right. The other announcement is something that I stumbled on, is that Helm Hub is now Artifact Hub. So if you've been working a lot with Helm charts, this has been a great resource to find your charts. Since basically, as you know, the official Helm chart registry is going end of life in November. It's already just in maintenance mode, and that means that you need to find alternate repositories for your Helm charts. And how do you find those? Well, Helm Hub has been the way of doing that. Now it's Artifact Hub. So at Artifact Hub, what's nice about it is it's not just Helm charts. It's operators, it's image, I believe Docker images as well, and other kinds of things in the CNCF ecosystem or CNCF adjacent ecosystem. So yeah, 2,100 packages, 39,000 releases, and it also supports filtering by different facets here, so you can find what you want. So whether you're searching for only official repositories, because that's another thing, is like there's so many duplicate charts out there. How do you find the one that's official by the vendor itself? Cool. Any questions about Artifact Hub? All right. And yeah, then just a teaser on some of the great stuff coming out of Cloud Posse this quarter. This is stuff that's been more or less scheduled and should be done by this quarter. One is, as you know, we manage a lot of Terraform modules, specifically some around EKS. What we do is we treat every node pool type as a different kind of module, because you can mix and match how you provision your node pools. You can have managed node pools with self-managed node pools, with GPU node pools, with Fargate node pools, and all of that stuff. Well, one of the things we're going to be adding is a node pool type for SpotInst, the service, spot.io. Managed node groups, and these are really rad, a lot more powerful than the type of Spot node pools that you can do just with what's available in the Amazon ecosystem itself. What Spot can do is, for example, is swap out instances based on what actual pods are requesting, because the Spot Ocean controller is aware of what kind of workloads need to be scheduled, and it'll just make those available. Also, because they manage a fleet of Spot instances for presumably thousands of customers, they have the best insight into the market economics for the Spot marketplace, and know when instances will be getting preempted with better accuracy than others. This means that they can preempt instances and move and cordon and drain your nodes sooner than you could if you were just relying on Amazon's marketplace metrics.
Yeah, yeah. We had actually engaged them, I think, a couple of months ago. We're looking to revise our pipeline as well. At the time, we didn't see the value of it. I think we pretty much jinxed ourselves at that point as well, because we then had a major reclaim of our instances after that whole conversation. So right now we're actually looking to revisit our architecture and actually see if we can actually implement a bit more intelligence in terms of how we actually request or Spot instances based on market metrics as well.
Doing it yourself or doing it via Spot?
We're thinking we pretty much engage Spot for this as well. Yeah, because we're potentially going to actually increase our usage within our pipelines for like encoding assets. And we just need to get to the point where we can actually take on that level of volume as well, you know?
Yeah, I think it's wise to start with that before you at least engineer some other complicated solution, because it's a quick win.
Yeah. I would definitely look forward to what you're offering here as well. I'll keep an eye out for that.
So then somewhat related to that is, in the Terraform side of things is the Terraform Cloud support. So we're investing a lot into Terraform Cloud as one of our continuous delivery solutions for Terraform. We were early adopters on Atlantis, and that got us very far. But I've kind of since wanted to have a fully managed service, deploy a whole lot less infrastructure to manage just the continuous delivery pipeline side of things for Terraform. So Terraform Cloud support is coming. We have the modules are already there. The pull requests haven't all been merged yet, but that's coming. It's early days, so expect some interface changes perhaps there. Related to that is reference architectures. So we've this year, starting in January, revisited our entire strategy to how we do Terraform. As part of this is taking an approach that works well on the CLI side of things, on the local development side, as well as is very well instrumented, orchestrated with something like Terraform Cloud. So that will be released in bits and pieces as this reference architecture. We've had to do all this other plumbing just to get to this point. So I'm hoping next month or so is when we get to start populating our reference architecture repo with some kind of stacks and blueprints for how that would work. Datadog, we're doubling down on Datadog. We've already released that module. There's more good stuff coming from that, including more canned alerts for Datadog. Because here's the key thing, like you can use Datadog really easily, but knowing what you need to monitor, that's half the battle. So providing those alerts for you. And enhanced integration with OpsGenie. We are adding support for now teams and services and user management as well. The PRs for that are up right now and should be merged this week. And just lots of other good stuff. So stick around, on office hours is when we announce when all these things are released. I even missed our CLI tool that's coming out, which works together with our whole strategy and with Terraform Cloud, and is just designed to make cold starts a lot less cold. Make cold starts warm starts. All right. So we are in that time where we can get to answer your questions. Sorry, guys. The last couple office hours, we haven't really gotten to any questions. There's so many announcements, and we had guest speaker Anton. So I'd like to talk today about one of the questions from Matt Gowie. He was asking recently, how are folks managing service environment variable configurations when working with Kubernetes and Helm? So I'm going to open up the Slack message itself. Let's see here, office hours. Thought I'd pinned it. So I want to open up the message because Matt adds a little bit more context to what he's doing.
Yeah, I think I have a pretty poor solution in place right now that I inherited.
It's close, but I'm gonna tell you how you fix it.
Yeah, I appreciate it. I think I have a solution in the the solution in the back of my head is like would work, but yeah, I'd love to see what other people are doing.
All right. So Matt's a contractor. He's available for hire. So if any of you looking for DevOps, reach out to Matt here. He's working on a client project. They have this pattern where they're using like raw OS level environment variables that are loaded in the values.yaml. This is presumably with Helm file, Matt, or no?
No, this is actually we're using Flux.
Okay, gotcha.
Yeah, and Helm operator. So another decision before my time, but
yeah. Okay, so it's mapping raw environment variables in the Flux CRD and passing those along, and then the problem is what to do with secrets. And what they're doing today is the secrets are provisioned out of band by Terraform in the cluster as a secret, and then the Flux deployments assume those secrets are there, and then use like ref mapping to mount those secrets or configurations like this. That's accurate?
Yeah, that's it.
Okay.
And it just basically the problem is to sum it up is that configuration is driven from two locations, right? Like, we have Terraform that outputs values, and then, the Helm chart is responsible for mapping those values to environment variables. And it just seems, in my mind, it could be done much simpler.
Yeah, so this has come up. This is a frequent pattern that's come up a few times, like how to manage secrets with Kubernetes, and also how to get that to work with your continuous delivery workflow. The common pattern that always comes up is using SOPs, right, with encrypted secrets that are committed and get released alongside your apps. Which is not bad if you like that, and it's really nice end-to-end automation. I just don't like the lack of opaqueness, or it's very opaque rather in the pipelines. What's changing, and in Git, there's this file that somebody has to have full access to decrypt it and re-encrypt it, right? Which is less than ideal.
Yeah.
I'm not going to say I have an answer for that. Like, how do you originate secrets for these environments, the pattern, honestly, for originating them that is most common is somebody sets them somewhere. Somebody's setting them either in GitHub and encrypting them. Somebody's setting them in AWS Secrets Manager. Somebody's setting them in Vault. Somebody's setting them in SSM. Somebody is setting them somewhere. Not every kind of secret is generated, and that is going to be up to you. The part that we can change is the system of record for those secrets. And the problem here is if that, Terraform isn't necessarily the best system of record for that, and it's going to be in Terraform state. And Kubernetes isn't necessarily the best system of record for that, because you might need them in other services deployed outside of Kubernetes, or multiple clusters, or things like that. So having the secrets originate in something like SSM is a first good step, right? Then the question is, how do you get them into Kubernetes? So what I like what you're doing is that the pods just reference secrets by name and not by value, so that way it's more secure, and the pods just come up and assume that those secrets exist. So how do we get the secrets there in a better way? And that's where the operators come in. And there's like at least a handful of operators for managing the process of getting secrets from HashiCorp Vault, or from SSM, or from ASM, or from 1Password is one I've seen, and others. And what's pretty interesting about that is then you offload that responsibility of how to set the secrets from how to consume and distribute the secrets. So it's a simpler problem. So if what I'm talking about, you probably heard is like the AWS secrets operator. There's a few of them here. Let's see which one. Yeah, so our very own Mumoshu, who's very active in our community, he has his own that works with Amazon Secrets Manager. And then there's the one by GoDaddy. And then there's one by Container Solutions. I'm going to see where that one is. This one, external secrets operator. But by looking at these, you get the gist of the pattern. So with external secrets operator, this one here, I believe this is the one that supports 1Password, for example. And this is just, what's interesting about this is now people don't even need access to AWS. You can use the standard best practice of how to manage secrets organizationally speaking, whether or not it's infrastructure, with 1Password. You can add users or remove users to teams of vaults that are managed by 1Password. You have the audit trails of those, and it's super user friendly. So that's one part I really like about it. The other thing is that you can, so this supports Keybase, it supports Git, it supports AWS Secrets Manager. GoDaddy is the other popular one I see come up a lot, and it supports the SSM and ASM. And what you end up doing is you deploy a different CRD, like external secret in this case, and you reference what you want it to look up, and then it writes a secret with a corresponding name. So that gives you a way of automatically managing the secrets in Kubernetes.
Okay, so I could see, I mean, we're, following what you guys do with Chamber and SSM. Like I use that in one of this client's CI pipelines. And I could see this being useful. But in thinking about it, if Terraform is driving, where those secrets get created.
Terraform is one source for those secrets. And those secrets write to SSM. So SSM as a system of record is a good place to start. So yes, we've been using a lot of Chamber in the past historically, but this year, I can't remember any engagement we've used Chamber on anymore. The reason is Helm file natively supports SSM now. So if you're using SSM, there's little reason anymore to continue using Chamber with Helm file. And if you're using Terraform, Terraform supports SSM natively. There's little reason to introduce Chamber. So the value is diminishing for Chamber.
Gotcha. Now, so in your Helm files, you are doing a environment variable name to an SSM secret name mapping.
Environment variable being overloaded. So there are,
or maybe it's a file, but
they're
yes,
like runtime environment variables for my CLI tool, like Helm file. There are environment variables that I pass to my pods as settings. So yes, we are using environment variables to pods to pass configuration information, like 12-factor, but we're having Helm file get the values directly from SSM.
Got it.
And I don't know if I have.
Eric, sorry, the question about Chamber. So you say that you are not using Chamber anymore, but when you are using, let's say, not Kubernetes, but let's say you need to provide secrets for the application without any Helm or any other mentioned ways, is there any alternative or any drawback to Chamber? Because I was using Chamber quite successfully, I think 2-3 years ago. I don't remember when.
Yeah.
And it was pretty good.
I don't mean to pass any shade on Chamber. Chamber is still a great tool. It's just that there's so many alternatives depending on how you're doing it now that it's diminishing returns. So like if you're using ECS, you can natively access SSM parameters. If you're using Kubernetes, we have these operators to do something similar. If we're using Helm file, it talks to it directly. So that's why we haven't needed to. But yeah, if you're deploying something to a classically managed EC2 node in an autoscale group, yeah, why not use Chamber probably to get those SSM parameters.
Well, also, there is nothing wrong or nothing bad with Chamber in the recent
years. There was a period of time there before they increased the rate limits on SSM that it was kind of problematic, but now the rate limits are much more reasonable. I think it starts at 1,000 and you can request up to 10,000 requests per second against SSM.
Yeah, right. Okay, good. Thanks.
It was 30, so.
Yeah, thanks.
Yeah. No, so keep using it if you're using it. No reason to reinvent the wheel. I was struggling here with a brain fart trying to look up the syntax here. It's a little bit weird how to do it. AWS SSM star. Yeah, what was it just? I think it was AWS S. Okay, that's probably it. Commits. So it uses this weird syntax like this, but anywhere in Helm file, and note, these are not in a Go mustache notation. These are just raw string like this. Helm file looks for this raw string and will resolve it. And this protocol scheme here of AWS SSM is just one of them. It supports Vault and ASM and many others. I think it even supports SOPs maybe. So directly. Cool. Any questions on that? Or other things you'd like to add to it?
I think I'll need to look into the external secret providers or operators that you mentioned, just because, yeah, I'm wondering where I would go with those, but personal learning, I need to dig into them.
So I would say it's like what I think what might appeal to your customer about using this operator pattern is that they're already using Weave or Flux to do it, so that they're already bought into this Kubernetes form of automation, and you don't necessarily need to get off of it unless that's not working well for them. If they're not using that and you're just going to use CLI-based deployments with like Helm file, then you might want to just consider skipping the operator and just using this directly, and then using this AWS SSM :/ notation in your Helm file. Yeah. The other considerations are also like if you're going to be tying in a continuous delivery framework like Argo CD or Harness or things like that, when these secrets are needed, like before or after that deployment. So, all right, that was a good question, and let's see what else we have on the docket for today.
Thanks for going through it.
Yeah. So, no doubt, Andrew, I bet you've already found the answer to what you're looking for here, because this has been here for like over a few weeks since you first asked it. But I thought it could be interesting for others since it's a cool little pattern that we stumbled across to do this. So you had originally asked, when using, so here's the thing. Cold start problems with Kubernetes and Terraform, a lot of the providers work that they assume they need to connect to the cluster before anything even starts up. So you need to have a dependency set up where you block that provider from connecting to the cluster before it's ready to come online. And what we did was inspired originally by parts of what they did in the EKS, the Terraform AWS modules EKS cluster. And then we extended that a little bit different with a very succinct one-liner with a single succinct one commander for how to do that. So let me see if I can find that. Oh, I thought it was you, Andrew, but I guess it was Oliver. Sorry.
Ah, I see what you're saying.
Yeah.
I was like, I don't remember what question we're talking about.
Yeah, sorry. Okay, brain fart.
No.
So
a little plug for Rancher, since I'm such a huge fan of Rancher lately. There's a Terraform resource called Cluster Sync or whatever. It just sits there and waits for the cluster to report that it's active, and it's got a bunch of options for it and stuff. So I thought that was amazing.
Does it only work with Rancher, you think?
Yeah.
Or would it work with other Kubernetes?
No, just Rancher. Just the Rancher.
That's cool. That is the missing
API.
In the EKS ecosystem. And Oliver, are you on the line? I think you might have said you couldn't make it today. Yeah, so anyways, since I started, I'll finish it here. Terraform AWS EKS cluster.
And I think you're going to be looking at the exact spot that I linked to answer his question.
Oh, sweet. So it's in there?
Yeah.
This is the trick here. So we do depend on local exec. All the solutions out there you will see depend on a local exec. What's nice about our local exec is that we're leveraging curl to its fullest. So curl automatically supports retries. Curl automatically supports retry delays. Curl automatically will retry connection refused and support insecure connections. So we're using this command here against the Kubernetes health check endpoint to block until the cluster is online. And we just call that with local exec somewhere else.
And you're not even checking for like a 200, you're checking for like a 403, right? Which is because you need authentication to talk to the Kubernetes API. And so you're just looking to make sure that the Kubernetes API is awake enough to go, you're not allowed to talk to me.
Yes, exactly. until it has the courtesy of saying, shut up and go away.
Yeah, right. I think the downside is that if you make it so that there's an option in EKS to make the Kubernetes API private, like in only accessible from within the VPC or whatever, then this doesn't work, right? Unless you're also running from within that VPC.
No, you're totally right. You are totally right. Thank you for bringing up that caveat. This only works with a public endpoint. It's also something that, so you have two options in that case. Is you got to run it. You got to run Terraform with something like a
Bastion or something.
Bastion or a runner or Atlantis in your VPC or any one of those options, or you just concede and you make it public initially, and then you have a separate phase where you shut it down. This is really a cold start problem, and when you're operating, a cluster as a platform for multiple teams, multiple divisions, you are not destroying these things all the time.
Yeah.
All right. So that was a good one. And let's see here. So yeah, this is also an oldie but goodie. It's come up before, but it was re-asked recently, is kind of how are we pinning our Terraform modules? And this is near and dear to our heart because we opened about 150 pull requests the wrong way and merged 150, tested, and then merged 150 pull requests the wrong way. And it was a real waste of human effort. So let's see here. So yeah, so this was a poll that was started. And let's see what the consensus was. 10 people voted on Alpine, Terraform, and the providers. And then this is not covering like the pinning strategy itself, meaning like, are we using, are we pinning to the major version? Are we pinning to the minor version? Are we doing lower bound pinning and all of those? So what Cloud Posse did wrong was, well, okay. Going back to Terraform 0.11, what Cloud Posse did wrong was we did no pinning. So when Terraform 0.12 dropped, we got slammed with a whole bunch of PRs that our modules are broken and don't work on Terraform 0.12, and Terraform 0.12 was released 3 hours ago. So yeah, that was true. So what we learned after that was, well, we need automated tests and we need to have provider pinning. So we added provider pinning. We did strict provider major pinning. So we didn't care about the patch, or no, minor pinning. We didn't care about the patch releases, but we cared about the minor release. And that worked well for a whole year. We had automated tests everywhere. Tests that we didn't have before. Then Terraform 0.13 drops. So the obvious thing was, okay, we are just going to change the 12 to a 13 everywhere we had it. So for pinning the Terraform core version. And to make this a little bit more precise and I guess clear for those following along on the video here, if we look at versions.tf, this is the file I'm talking about. This here is called the core core version pinning. So providing the core. This is doing what we should not be doing. We did this in a whole bunch of places. So what this is saying is that it works with Terraform version 0.12 and 0.13. But when Terraform 0.14 drops, we're going to have to update every single one of our 100 plus Terraform modules before we can even run one test on our modules on Terraform 0.14. So there is zero value for us to do upper bound pinning on the core versions of Terraform. The reason is that modules depend on other modules, that examples depend on other modules. So we will have an example that depends on the Terraform VPC module to create the VPC and the Terraform subnet module to depend on Terraform subnets. And then we'll deploy Terraform Elasticsearch. And then we'll need to deploy a Lambda for cleaning up the indexes on Elasticsearch. And that's how we do a complete example for our module on cleaning that stuff up. And the problem is that if we have upper bound pinning on the Terraform core version, all of our tests will always fail until we update all of our other modules. And then all those other modules have similar dependencies because their tests depend on other modules. So we have this very complex interconnected graph of version pinning everywhere. So this is why HashiCorp has on their documentation officially recommends do not pin the upper bound of your Terraform core version. And I can dig that up somewhere. Somebody else shared that with me. So what we are doing is pinning the last known working version based on our automated testing infrastructure. And in this case, it's 0.12.
I want to add to this one. I also do very similar things, and maybe you discussed it, but I just came back. So yeah. The situation which is kind of leading me to this approach is that we are not sure that Terraform 0.14 will be still working, because there may be some backward incompatible changes, and we have no clue what's going to be released.
That's true.
It will probably be okay, but still one backward incompatible change in Terraform will simply make this module useless.
You're right. And you're right. And I think you can work around that problem if you are, first of all, if you are your own company's organization and you operate in a monorepo and you have lots of control over those things. But in our case, we have so many, same as you, Anton, I mean, with the Terraform AWS modules, is all these other modules. And I don't know about how your tests work, but if your tests are leveraging other modules to do your test, then you're back to square one. So this is our final position on open source Terraform modules should just do lower bound pinning. And then your root modules should do more precise minor version pinning. And I think it was actually Lauren who shed the light on me and convinced me that that's how we should do the pinning.
And I think what you're doing is much more correct than official documentation says. I didn't check it for quite a long time, but they were actually recommending to use not tilde sign, but use more equal.
So that's what we've switched to now. So if you look at this, my current on my bucket, we're using the greater than or equal to now. So for better or worse, this is what I've conceded is the only feasible way to manage our connected graph.
But line 5, where you specify AWS more than 3.0, does it mean also AWS version 5?
Yes.
4, 6? And are you sure that your module will be forward compatible?
I am not, but I am not positive about that. But I am 1,000% positive that our testing infrastructure cannot test that scenario because of the graph. And that's the problem.
This is where we have to rely on the user to some degree and rely on them following HashiCorp's best practices also. They have to pin in the root module where they are using this module. That's where you use the tilde.
Yeah. Look, from a point of correctness, I agree with you totally, Anton, and that's why we were doing it. But if you look at our Git Cloud Posse organization, and the number of pulls we needed to do because we did this the wrong way, it really freaking hurts.
I completely can imagine what you're trying to find, because I was in the same position and I was desperately looking for a tool which I can just use to automatically fix one thing and then open 30 pull requests.
There is a tool for it.
We got that for you.
Yeah.
We just used it wrongly.
Yeah, Matt Gowie found it. He helped us do a lot of this, and you might like it, Anton. It's called a microplane, and it's a tool for that. So check it out. It's come up on other office hours as well, and I'll share it in the channel here. The idea is you write a script in whatever language you want that does the migration, and then you give microplane a query to go clone those repos, run the script, open the PR. It can even merge them, I think.
Right. I actually use this tool myself.
Oh, sweet. Okay, so you know.
I see this by link. Yes. Yeah. So this one is one tool which I replaced my previous shell script.
Yeah.
My previous shell script was doing the same, but just in a loop.
Yeah.
And I was a little bit worried that it will work or not work. So yeah, thanks for pointing this again.
Yeah, no, it's cool. It works. The danger with automated pull requests is if you have branch protections enabled and automated tests from the public repos and stuff like that, this part is automated. The merging and running the tests and fixing the tests that break, not automated. So we did a Cloud Posse denial of service attack against all of our contributors when we did this. It was brutal.
Another thing which I was looking at some point is to manage more. So versions TF file currently is rather dynamic because different providers are used, different versions and so on.
Yeah.
At some point I was looking into GitHub file provider, which I'm sure you guys are aware about, which allows to actually open pull request and change files.
Yeah.
It has a lot of issues. I think GitHub file in one word. And that's name of Terraform.
Yeah, I do recall seeing that. Oops, I clicked the wrong thing by accident. I do recall seeing that. I only like in passing and think, that's cool, but it never looked into trying to use it.
It has a lot of issues. So I managed to use it with Terraform 0.12 to create to create files like license and .github ignore and a few other very static files, and it was working fine. But with Terraform 0.13, there is no pre-made package, and I couldn't compile it. No, not Yelp. I think by someone else, actually. Yeah, you see, it's pretty hard to find because it's not very active.
So my gut is I wouldn't want to use this, mostly just because I hate. All right, I would like it to be a kind of. I don't want to have to manage Terraform state and manage GitHub state for managing a file in GitHub. Like, I just want a stateless tool at that point to help me manage GitHub as my state for my state file. In that case, that was a little bit arbitrary, awkward, but I don't want to have a state backend in order to manage my files on GitHub.
Exactly. I'm completely with you on this. So that's why this was the only use case when I used Terraform Cloud to store state file there. It was actually a valid use case because I wanted to try Terraform Cloud to see how it works.
Yeah.
That's it.
Yeah. So related to this, there's a couple of tools that were brought to my attention I wasn't familiar with. This guy, Mina Mijoyo, has a whole bunch of rad Terraform tools for manipulating HCL. So this is one that will very easily help you modify your HCL code just using a simple CLI tool, almost like you would use JQ or YQ or some of those other things to manipulate JSON. And he also has some like HCL update tool, DF update, which will help you automatically update pinning in your HCL code. So looking at some of these tools, introducing that into our future workflows.
And also talking about this guy, I also like his other project, TF Migrate, I think, which is pretty interesting. And yeah, I really like when people are contributing in all possible directions.
Yeah.
It's like if he is smart, then he creates a bunch of different tools all over.
Yeah.
That's pretty cool to see.
Dependabot.
Oh, go on.
Dependabot doesn't work for Terraform, does it?
Lauren, you want to take that one?
I mean, Renovate bot works.
Yeah.
Oh, Renovate.
Yeah, Renovate
What
bot
is it?
works.
What's it called? Oh, Renovate.
Yeah. There's also a GitHub action. There's been a pull request that our one of our prior contributors developed for Dependabot, and it's been sitting there for about a year and a half, I guess.
I think it's actually quite hilarious to have such long-running issue where I at least see how you guys look. I mean, I see your usernames. Pretty much everyone is familiar in that pull request.
Yes.
It's so funny, and how request was for 0.12, and then Eric says, "Hey, now let's update it to 0.13."
Thankfully, the syntax didn't change.
Yeah, and now this was I guess it was this other one here, 11.76. Yeah.
But yeah, there is a GitHub action if you like Dependabot and kind of some of its functionality, and you're comfortable using it, and you don't want to start using Renovate Bot. You can use a GitHub action to run Dependabot in a container basically for you.
Yeah.
You just put it on a schedule instead of having it. You don't get all the same kind of functionality that you do from the Dependabot service. It's just what they do in the container.
Yeah, I'll share this thread here. Lauren's company, they have a fork of it that has some bug fixes, and then there's another company that has it.
Yeah, our fork. We do a lot of stuff in code commit also, so you don't need our fork necessarily. Whoever it is that actually created the GitHub action, that one works just fine. We use ours because we do a lot of things out of code commit, and we have other pull requests open there on the Dependabot repo, adding that functionality. Sitting open, of course.
Yeah, so where I'm leaning is I'm somewhere in between, maybe using Renovate Bot or maybe using TF Update from the other repo we were just looking at, and then to save everybody a whole bunch of grief, because I think everybody who's tried to use something like Mergify thought, okay, maybe I'm just going to first try and get it to work in GitHub Actions. You can't get it to work in GitHub Actions. It's impossible. We've wasted 2 weeks of man hours with different hacks trying to get it to work, and nothing works. So then Mergify to automatically merge those pull requests once they pass your tests, once you have the updates and everything else.
One of the things that I like about Mergify in particular is, and maybe Dependabot can do it also, but it has the ability to just comment directly on your pull request. So you can kind of set up triggers. The thing about having an open source project is you don't necessarily want like any new pull request running all of your tests when your tests might cost you money, right? You only want like that pull request that you want to approve it specifically. So you can set up Mergify with a series of triggers that, like, if this pull request is changing this file kind of thing, then maybe I do need it to automatically run everything. And so you can have it create a comment, and then you can associate a comment on GitHub to some webhook somewhere, that will trigger a build. So you give Mergify basically permissions then to comment, and that comment is what triggers the build.
Okay, that actually simplifies a lot. Just saying that, since that's like our test all, right? So we can have merge it. So we'll have Dependabot or whatever open the PR. Mergify sees it's from Dependabot user, adds the comment test all, waits for the pull request to be mergeable, and then merges it. And then I saw, Mergify lets you have branch restricted to certain branches, restricted to all these other, and it's free for open source. So
it is, and it's a very active project. It's one of the ones that I subscribe to. It is continually updating itself and improving itself. Like, those guys are very, very on the money. Yeah.
Okay. That was the other thing. I was just concerned about giving that much power to a small project, what seemed like a small project, but Mm-hmm.
Yeah.
Cool. Anton, I saw your post. Was it a call for help to automate some of the Terraform AWS modules with GitHub Actions? Was that right?
Yeah, that was right. But I think I got a significant amount of response. I just delegated to one of our active contributor who actually has all experience which we need. So the work which we want to do is just streamline how GitHub pipeline or GitHub action actually work. I mean, you all guys have developed all of this already. Most likely our job will be just to figure out which parts to take from all of you and commit.
Yeah. It's one of these things.
Rocket science at
test
all.
Infrastructure ends up being very cultural or organizational. Like the Kubernetes project, they have their whole test infra repo open source. I don't know anybody leveraging it for their own projects, but it's it's something to take a look at. We ended up also doing our own test infrastructure for all the Cloud Posse stuff, but it's very special to what we do. And I'm guessing Terraform AWS modules will end up being also very specific to your alignment and the tools that you use.
Yeah, absolutely. I wanted to do it slightly differently though, because I'm really sometimes thinking that I'm repeating myself way too many times. Like if I apply this change in one repository, there is huge probability that I will apply the same change, the same fix, the same version bump, or something very, very similar in other repository. And this happens pretty much if there is small bug or small issue somewhere in Terraform. I don't know how, but people discover them in several repositories at once.
Yeah. Yeah, well, we'll be keeping an eye out on what you figure out for that. That sounds like a hard thing to solve.
Yeah, it is.
The gist of how we're looking at it is hopefully the fix is in an upstream module, and then through automatic dependency management, that automatically trickles up to all the others as we fix it upstream. Then all the modules that depend on that will get a PR to link to that new version, and we kick off the tests automatically for that. And then we merge that. But actually replicating the fix itself, that sounds like
that was one of the things I liked about your build harness actually, and how you manage that. Publishing that in a Docker image is really useful, because then you have a simple hook that you can drop into every one of your projects in the make file, right? Just the include statement, and you can have a little Docker file that will pull, the latest version of, or you can just have a Docker file that specifies the latest version of whatever your build harness is, and then you have Dependabot, open your pull request for that Docker file. Like
exactly,
so, there's a lot of moving parts, but
it's a lot of moving parts, and I don't expect everyone to get it. But it was absolutely required for us to manage this many projects with such a small team.
There are a few things which I want to add, in regards to your HCL edit project, which you already covered.
Yeah.
There is another project which is called HCL like Q as JQ. YQQ.
Oh, HCLQ. Interesting.
Yeah. On GitHub. So this project was working the first one. This project was working quite nicely with HCL1. And if you still have, let's say, simple HCL syntaxes where you don't use a lot of HCL2 magic, you can still use it. So it's like JQ, YQ, but for HCL files.
That is.
And there is also an open issue where they are working on support for HCL2. I don't know how active is it, to be honest, because I think it was like having some attention at some point, but then I don't know what's going on actually. So for simple things, it works. And if you have Terraform 0.11 project, it will definitely work.
and if you have that Terraform 0.11 project, let me just, I'm sorry.
Yeah.
You have a little bit of catching up to do.
Soon this is gonna to be the only tool which work.
Yeah.
And another project which I think you mentioned about open infrastructure, there is a website called infrastructures.org. .org. Yeah. So this is a really ancient website.
I was going to say, not even TLS.
Yeah. And the point of this is that if you click somewhere on these links, somewhere, I don't remember even where, you will see a list of companies who are keeping their infrastructure open. So you can actually, honestly, I don't remember where to click right now, but there is information about companies who had some configuration open and they expect people to commit code or to see how maybe they can learn something from that. So it's pretty cool. I think they changed actually something, so I couldn't find where this link was. But there was link or like 10 or 20 different websites where you can see like, oh, this company I know, and they actually have infrastructure on GitHub, which was pretty cool.
Yeah, that is cool. And in that vein, there are like these awesome lists, right? I think I've seen something out there where a lot of companies have published their like their root modules or their infrastructure repository that they use for what they do. It tends to be very like specific, but it's a great calling card, I think. If you want to see what it's like working at a company, to see what it's like looking at their infrastructure. Yeah,
GitLab, Travis, I think they're pretty famous for that.
Yeah. GitLab is, yeah, just trying to remember what I saw. Wanted to bring, never mind. All right, let's see here. Oh man, we went way over today. Sorry, this was so much fun. I just lost track of time. We will leave the rest of the questions to next week. Probably have more announcements coming from HashiConf as well. So stay tuned to listen to that next week. For all of you that attended, thank you so much for participating. It was an awesome session, so much so I lost track of time. If you stick around in the Office Hours channel later on today, we're going to post a video recording of today's session. We'll also syndicate that to our YouTube channel with Cloud Posse, as well as like to have a one-on-one session with me or someone here at Cloud Posse, feel free to book a session by going to cloudposse.com/quiz. Again, that's cloudposse.com/quiz, and we look forward to the possibility of working with you. Have a great week. Talk to you guys next time.
Thanks again, Eric.
Thanks, guys.
Bye.
Bye-bye.